Welcome to Session 4. Today, we move beyond treating a task as just a sentence. To build a real application, you need to structure your tasks as records that include a description, status, tags, and a unique identity. Why is loose text not enough? A simple string only holds the words. A structured dictionary allows your application to filter, complete, save, and report on tasks by tracking specific fields like ID and status. By the end of this video, you will master 3 core skills to manage real data: creating structured records, storing them in lists, and filtering them safely without losing information. Let's clarify our terminology. A dictionary represents a single record with key value pairs. A list acts as an ordered collection of those records. Use a dictionary for one thing with fields, and a list for many things. Here is the standard task record shape. Consistency is vital. By ensuring every task uses the same keys, your later code can safely interact with any record. Think of it like a job application, where every record shares fields like ID, role, and salary. Let's look at the code. Curly braces define your dictionary, and square brackets are used to retrieve the values. Using a consistent shape here ensures your future code remains robust. When you run your code, look for your specific task description in the output. If you encounter a key error, it usually means a key is missing or has a typo. Double-check your spelling against the record shape. For step 2, we move our logic into an add_task function. This function encapsulates the rules for generating a new ID and setting the default status. Remember, list appending is a mutation, and returning the task makes it available to your caller. Visualizing the change is helpful. Before calling the function, your list is empty. After the call, the list grows to include your new dictionary record. Just remember, do not use the list position as a permanent ID. Always search by ID. To prove your code works, run the reference solution and compare its behavior with yours. If your IDs repeat or reset unexpectedly, don't worry, as this simple ID strategy is only temporary for practice. Step 3 is about filtering without destruction. Creating a filtered view, such as a list of only open tasks, allows you to display specific information without removing the original records from your database. You can read a list comprehension like plain English. Start in the middle. For every task in tasks, keep it if the status is open, and then put it into the new list to be returned. Verify your filter works by checking that the original list remains intact after the operation. You should be able to see both your open and completed tasks in the original list, while your filtered list shows only the open ones. If you run into issues, treat them as data shape mistakes. Whether it's a key error or an unexpected tag issue, the best debug habit is to print your data before modifying your code so you can see exactly what you are working with. For your independent exercise, try writing a function to complete a task by its ID. Remember, the goal is to update the status of the record while keeping the data structure consistent. This slide connects our code to the web interface. We need structured records with IDs so the browser can accurately render buttons, tags, and filters. By mastering this mental model, we prepare our data for storage in a database like SQLite. As you practice, use AI effectively. Don't ask for code to replace your thinking. Instead, use it as a tutor to help trace your code and explain errors. This ensures you truly understand the logic you are building. This completes our checkpoint for Session 4. You should now be able to handle structured records, use filtering, and explain your data design. In our next session, we will add memory to our program using JSON and CSV files.